So we're doing a review of fractions, and we are going to start with finding fractions between other fractions. And for fun, I'm going to pick, how about 1/9 and 1/8. That's not the one on the table, is it?
No.
No, but it's the one that was on the homework assignment.
Everyone got a different one.
Oh, okay, cool.
Yeah, so I set that one up to do different ones. So usually what I like to do is draw myself a picture, so I'm just kind of going to zoom in on a number line. Somewhere on a number line lives the number 1/9. It has a bigger denominator, so it's a smaller piece, right? So 1/8 has to be to the right of that. If you're not sure, does anybody remember how to compare fractions or trick?
To average? Oh, wait.
Average is like, that'll find the middle, but if somebody says, hey, here's two fractions, which one's bigger?
Oh, drawing out the...
I could draw a picture, right? But sometimes I don't want to draw a picture. I could whip out my calculator. Sometimes I don't want to whip out my calculator. So what was the other technique I gave?
You just multiply the two.
You do a cross multiply. Yeah, so a cross product, you could compare them. So I'm just going to put that on another page here. So if I just needed to compare these two for size, like which one's bigger, I would just write them down next to each other like this. And then if I do that cross product there, 8 times 1 is 8, 9 times 1 is 9. Now technically what's going on here is I'm forcing a common denominator of 9 times 8, which is 72. So what I've just determined is 1/9 is the same as 8 over 72, and 1/8 is the same as 9 over 72. So here I can see that 1/8 is bigger. And I put it to the right, so that means I did the right thing. Okay? So this just determined for me that 1/8 is smaller and 1/9 is greater. Okay? And the cross product, really all I needed was the numerators to figure that out. If I just wanted to say, hey, which is bigger? And basically that gives a common denominator that's a product of the previous denominators. Now as far as finding numbers in between, when I had 1/9 and 1/8, now I have 8 72nds and 9 72nds. I'm really not much better off than I was before, because what whole numbers are between 8 and 9? And the answer is there are none. So that's a slight problem. But I gave a trick to expand that. Does anybody remember the trick I gave next to find some options in between? Yeah, multiply both of those by some other number, like 10 or 100 or whatever you want. Okay, so I'm just going to go for 10. So what I'm going to do is I'm going to multiply top and bottom by 10 here, and here, and here, and here. So another form of 1/9 would be the number 80 out of 720. And another version of 1/8 would be the number 90 out of 720. It's the same fraction, it just looks different. But now, can't you name a whole bunch of fractions in between that are proper fractions? Yeah, 81 out of 720 and 82 out of 720. So I can list a whole bunch of them. And if you needed more, then multiply by 100 instead of 10. Then you have tons to choose from. Okay, so that was one technique, kind of making the denominator bigger and bigger until I can see some numbers in between. Okay, and like the first time I ever did this, I remember going to 72, and I'm like, surely 72 is big enough to find some numbers in between. And I'm like, oh my gosh, it's still not big enough. Surprise. So I had to try again. Another technique which was related to the homework problem that you had to do was, if I want, I could find a number exactly in the middle. And given two numbers, the number exactly in the middle would be their average. So that would be another way to go about it. So I just want to review average, because it also reviews an algorithm. Way back to last quarter, we talked about average. Average means to find the sum of the numbers and divide by how many, which I also call the count. So in this case, the sum would be to take 1/9 and add 1/8. And the count is, well, there's just two of them. So add them up and divide by 2. So this gives me another option to talk about order of operations, which we haven't talked about much, but that's important. So let's complete this calculation. And a couple of notes. Some calculators, I love calculators, they're great for this. Some calculators, though, don't have a horizontal fraction bar, right? The division is a slash instead. So what would this look like on a calculator that doesn't have a horizontal bar? The thing to realize here is this big fraction bar basically says, hey, you gotta calculate the top before you can do the division. Does that make sense? Are we gonna do that? So if I write that out with a slash instead of a horizontal, that means I have to take one slash, take my 1/9, add it to 1/8 with the slash, like my calculator has. I have to do that first and then divide that by 2. And I could just type that into a calculator and the calculator will spit out an answer, but what kind of answer do most calculators spit out? A decimal, which I don't necessarily want, and there's ways around that, but let's just go for this. We have a way to do this inner part here.
Oh.
Interesting. Fun with technology. So I'm going to rewrite it this vertical way again with the horizontal bar. And then the easy way to add fractions is that arrow method. So 8 times 1 is 8, 9 times 1 is 9. The common denominator is 9 times 8, or 72. And we're adding these, right? So 8 plus 9 on a good day is 17 out of 72. Now I just need to divide that by 2. Our division algorithm, we had 2 or 3 of them. How do we handle division?
You multiply by this.
Yeah, so what's the reciprocal of 2?
1/2.
1/2. So the alternative to this is to say, well, let's try 17 over 72 times 1/2. So algorithm for multiplication is the arrow across the top and the bottom. 1 times 17 is 17. 2 times 72 is 144. That sound right?
Yeah.
So it looks like the average is 17 out of 144. 17 is prime, isn't it? I don't think it goes into 144, so that's reduced. So it turns out if I wanted the number in the middle, it would be the number 17 over 144 would be exactly in the middle. That was a lot of work. If I wanted to keep finding numbers in the middle, I'd have to keep repeating that process for any 2 numbers I pick. So I could keep finding numbers in between. That would be another way to go about it. It's a little more work than that first method I showed over here. Not there. Where is it? Oh, where'd it go? Am I missing a page? Oh yeah, this one is it. Okay, right here I was looking for. Yeah, so we can find lots of numbers in between there. All right, so we get to do finding numbers in between, finding an average, a little order of operations, parentheses are important, and we get to review a bunch of algorithms. That was exciting. Questions on these? Not at the moment. Okay, so let's see. Let's do a multiplication model with mixed numbers. Page. How about, okay, for some reason I don't have a copy of that table. I just want to go back so I can do this one for you. Let's go with 2 1/4 times 3 2/3. And my recommendation for modeling this would be to use the area model. You could use the group self model. It's, I think, a little bit more work. So I'm going to choose to say multiplication is an area to answer this. And I think it's a good idea for these on paper setup, especially for me, and to make sure you're doing it right, is describe 2 things before you get started. What does multiplication mean? Or addition, whatever operation it is. So multiplication is area. Area is, for me, base times height. And then I also want to remind myself what I mean by a fraction, and that's an equal part of a whole. and you should write these things down. And so then I'll attempt to draw this. And I'm going to choose to kind of flip this a little bit to fit it on my screen. I'm going to make the 3 2/3 my base. And I'm going to let the 2 1/4 be my height, so it's easier to draw horizontally for me on this screen. So I want to show that area right there. So I'm going to draw myself a frame with a nice right angle. And I need to get 2 1/4 vertically on this screen. So let's say that's 1. So 2 is about there. 3 would be up here. 1, 2, and then I need quarters here. So halves, quarters, halves, quarters, halves, quarters. So that right there is my 2 1/4 for my height. And whatever you decide your first 1 unit is, try to do your best to draw 1 the other way too. So 1 for me horizontally is going to be about here, and then 2 is about there, 3 is about there, and I need to go almost to 4. 4 would be about there. And then I want to slice these guys into thirds. And I'm interested in that one right there. So that's my 3 2/3. And then my usual strategy here is to draw all the whole numbers first. So I'm going to start with the whole number just above my height. It's cutting across my words, unfortunately. And then 4 is over here. And then I draw in all of my whole numbers, the best of my artistic ability today. And hopefully they're roughly the same size squares. That's not too bad. And I'm going to use another number to draw the region I want. I want to go across here and then up from here. I'll add a little extra highlight on that. So this region here is my answer. So now I just got to determine what the answer means. What should I do next? Everybody?
So the rest of these were like the
Yeah,
four.
cut all the rest of the fractions. Cut all the quarters and the thirds. So then I'm going to cut my quarters. And my thirds. So other important things here, I need to be able to identify what's a whole, and a whole is 1 by 1. So that's one whole. How many pieces are in a whole? It's a 4 by 3 region.
12.
12. Okay, so I'm going to just make a note. There are 12 pieces in a whole. And then I can count up how many pieces are in my region. So going across, there's 1, 2, yellow, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So just a note, I could call this right here 11/3. Improper fractions are nice. And going the other way, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. So I could call 2 1/4 9 quarters. The nice thing about that is this region highlighted in yellow is 11 by 9, isn't it? So I'm just going to make a note about that. My area is 11 by 9, which is 99 small pieces. Oops, extra letter in there. So then I could just go right away and say the area is 99 out of what? 12. So there's one answer right away. Other ways to continue, what do you think I should do next?
Reduce the 99 over 12.
Reduce the 99 over 12, that's one option, okay? What's another option?
Convert it back to this one.
Convert it back to a mixed number, yeah, and you could go either way. I'm gonna choose to do a mixed number, so which basically means I wanna divide by 12. What does divide by 12 mean to the picture?
You're gonna make groups of 12.
Yeah, exactly. Right. So in other words, I'm finding groups of 12 to make a wholes. Groups of 12. So I'm just gonna, I'll do that both ways in the picture and with division. So there's one, oops, wrong color. Let's use red this time. There we go. 2, 3, so pick off the easy ones first. 4, 5, 6, and so now I can't find any square whole ones, but I can keep looking otherwise. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's another one right there. And can I keep going? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oop, there's another one right here. So what's that give me? 6, 7, 8, with what left over? Those pieces left over right there. So we can confirm that. Let's go to a new page. So I was left off with 99 over 12, and I'm saying, okay, 12 goes into 99 how many times? And it looks like it goes in 8 times. 8 times 12 on a good day
It was 96.
was 90.
96 because you have 3 left over.
Oh, 8 times 12 is 96, is what you're telling me?
Yeah.
Okay, there we go. I thought you said my 99 should be 96.
Oh, no, sorry.
Yeah, so 8 times 12 is 96, that is correct. And then I subtract, and I get, there's the 3 left over. So another version of this answer is 8 and 3/12. But 3/12 is really,
1/4.
yeah, so I can group by 3. And so 8 and 1/4 is another answer. So I'm hoping for something like that with a couple of explanations in there for that problem. Questions on this one? I'll see. Okay. Let's try division next. Let's see, what was the division problem on the take home? 3/4 divided by 2/3. No wonder that was stuck in my head. I was thinking I was going to do that one in class.
Because you did do it in class.
I did do that one already, so it's in your notes too. Score! Nobody would have missed that one. Oh, some people weren't here the other day. Who wasn't here? All of you were here? Were you here?
I don't know, which day was it?
Yeah, it was
Yesterday? Monday?
Was it Monday? I was
Yeah.
here.
You were here? Okay, good. All right, so I went over that Monday. Well, that's good. Okay, so let me think of something similar then. How about 2/3 divided by 1/2? Should be good. And the definition of division I recommended using here was groups in. So division means groups in. And then a fraction is equal part of a whole. So the question that this problem asks is what? What's the question I need to answer when I put all that together?
What is 2/3 of 1/2?
Almost. That would be multiplication. That would be multiplication also.
How many groups of 1/2 goes into?
Yeah, so we got to think of the goes into, so that's long division. So often what I do next for myself is I rewrite this as 1/2 goes into 2/3, and then that gives me my question. So, and there's a few ways to word it. One would be how many groups of 1/2 are in 2/3. So if you remember last class, I kept rewriting these as long division to help me think about what I was trying to do. And the other way is what Olivia said, which was how many times does 1/2 go into 2/3? You could think about it that way too. So I'm going to draw this on a new page because I'm just about out of room, but I need a representation of 1/2 and 2/3, and you could use the color rods to do this, you could use the pattern blocks to do this, you could use the square fractions I was drawing before, whatever you want. Okay, does anybody have a suggestion that they like? Yeah, the squares are what I drew the other day, but you could do anyway, so maybe I'll show it with, I could show this also with pattern blocks in a minute. So then I'm just going to draw 1/2 as a square. That didn't come out very good. Better. So here's my 1/2. And then I want that to go into 2/3. So I actually like to draw this out with the long division. And I'll slice the 2/3 the other way. And I'm going to use a different shading. And it looks to me that at least one of the yellows will go into the green region. So I got a little more work to do. What do you suggest I do next?
So I cut them to match each other.
Yeah, it turns out we do need equally sized pieces to envision this. Yep, so we'll cut the 1/3 in half and the 1/2 in 1/3. And basically now this breaks down to a new problem. I'm looking for pieces of 3 inside that group of 4 over there. So this breaks down to the question, how many groups of 3 are there in 4? Right? And here I can see, well, there's one group of 3 right there with 1 left over. And the question is, well, what do I do with that leftover? And the answer is, what am I looking for? I'm looking for groups of 3. Yeah. So it turns out the answer is there's one whole group of 3 there, and 1 out of those 3 pieces are left over. So the answer must be 1 1/3.
How
So
come
there
it's
are,
three?
so let me state the answer and we can talk about it some more. So it looks like, so I started with 2/3 divided by 1/2. And my answer seems to be there are not right. 1 1/3 groups of 1/2 in 2/3 is what seems to be the answer here. So just for fun, check this out with me. What does this phrase right here mean to you? 1 1/3 groups of 1/2. Groups of, what does that usually remind you to do? Multiplication, yeah. Can I draw 1 1/3 groups of 1/2? Yeah, so I'm going to try to draw that just to double check this. So here's one group of 1/2 right there. And then I need 1/3 of a group of 1/2. Let's see. So I don't want the whole group, so I'm going to have to slice this a little bit maybe. So would this right here be 1/3 of a group of 1/2 right there?
No, you would need another one, right? It would be 2.
So here's my claim. This right here is one group of 1/2. And this picture right here shows 1/3 of 1/2. Because I need to show 1 1/3 groups of 1/2. So is this piece right there 1/3 of that piece right there?
Yes.
Answer is yeah, it is. So I did just draw a picture of 1 1/3 groups of 1/2. Is that the same as 2/3? Let's put that all together into one big cake and see. So halves, and I need thirds. How many little pieces am I going to stick in there?
4.
4 of them. So I could put them anywhere I want, like 1, 2, 3, 4. What do I now have a picture of? 2/3. Yeah, so I just double checked my answer worked out. Okay, so let's go back to Alondra. You had a question over here.
No, just kidding. I was doing it wrong.
Okay.
Did I see my mistake?
Okay, so I'm going to do this one more time, but with the pattern blocks. Okay? So think about the pattern blocks. I'm going to add a page here. So I'm going to try to illustrate again 2/3 divided by 1/2, which instead we're going to look at 1/2 goes into 2/3. And often with the pattern blocks, we let one hexagon be a whole. So I'm just going to draw myself a little key on the side that this is one whole. What would a half look like for the pattern blocks? The trapezoid, yeah, so I'll draw that. So let's see, a trapezoid is 1/2. And what would a third be with the pattern blocks? The rhombus, yeah. So I'm going to draw my best rhombus to scale. I think it would be about this big. So that would be 1/3 of the whole. So redrawing that here, let's see if I can do this. I want to have 1/2 go into 2/3. And so for the 2/3, I'm going to have to draw the whole first and show my two rhombuses. Not too bad. And then here's one rhombus, and there's the other rhombus. Okay. So some shading. So this right here is my half, and I want to know how many of that size thing live in these 2/3. There's 1/3, there's 2/3. And there's a couple of ways to proceed from here. Anybody want to suggest a way to try and pull the answer out of this? Think about those toys that we played with.
So you could use that toy, like the red one, and put it in your shaded area and see.
Stick it on top and see what happens. Yeah, so if I did that, right, what would happen? I think that would look like, oops, that was supposed to be red. And it would sit right here, right? So this would be my, all right, so for sure there's one whole half in there. So then the question is, what is that leftover chunk? Okay, so what is another way I could think about this with those toys? There's a toy I'm missing here. Yeah, the green triangle. Remember the green triangle? So I could rewrite this piece right here as 3 green triangles. Goes into the hexagon. And the hexagon altogether is made up of 6, but I only want, let's use yellow. I have those 3 there, and then I have these 4 here. So based on this new picture, there's a couple ways to think about it. I could say the answer is there are 4 out of the 3 pieces needed. Or I can say I have one whole group of 3, and then what's left over? 1 out of the 3 pieces I was hoping for. So I could use those toys to do it too. Is this a mental challenge? It should be. Our point here is to rack our brains about what we think we know and why we think we know it. What's one of the, we had 2 algorithms for doing division. We talked about the multiply by the reciprocal. What's the other algorithm we had? Anybody remember how the arrow algorithm goes here? How does it work?
Cross multiply from the second fraction.
From the second fraction, we cross multiply. Yeah, so this 1 gets multiplied down there. That 2 gets multiplied there. 2 times 2 is 4. 1 times 3 is 3. And it turns out that should be the answer right there, 4/3 with the arrow algorithm. The question is, why are we allowed to make the arrows point that way? The answer is because this is what division means. It means look for groups in. The arrows are just a coincidence. It just happens to work that way. So a reminder about the different algorithms. And I'm just going to focus on the arrow algorithms right now. Arrow algorithms. Addition and subtraction have the same algorithm. So if we had something like 5/12 plus 7/20, the arrow algorithm says to multiply across the denominators for a new denominator. 12 times 20 would be 240 in this case. And then cross multiply 20 times 5. Cross multiply 12 times 7. And if you're adding, add. If you're subtracting, subtract. But that's the arrow algorithm. So according to the arrow algorithm, the answer here should be 184 out of 240. Works really fast. You may have to reduce after. Sometimes you do, sometimes you don't. If I use the LCD algorithm, might I not have to reduce? You still might have to reduce even with the LCD algorithm. You just have a smaller denominator to reduce from. Multiplication. Like suppose we had 3/5 times 8/9, for example. The algorithm we developed there is just multiply across the top, multiply across the bottom. So the answer here should be 24 out of 45. And then division, we just looked at, but I'll put it up again. Suppose we had 4/5 divided by 3/2. Here the arrows go backwards from the second fraction, opposite positions. So 2 times 4 is 8, 3 times 5 is 15, so the answer should be 8/15. So those are the different arrow algorithms. So there were 3 goals in this chapter. One goal was a refresher on how to add, subtract, multiply, and divide. Second was, are there different ways to add, subtract, multiply, and divide fractions? And yes, we have a couple of different ways for each. And then third is, why do those algorithms work? And that's what the models are for. Oh, sorry, hang on one sec, I gotta respond to this. Silence. Questions? It's a crash course the last 2.5 weeks. And we got everything I hope to do. So I'm going to stop the recording here and hope I can get that to YouTube at some point in the near future.